Okay, here we go. Angle, side angle, triangle congruence. So let's see if we can prove other sets of measurements that guarantee triangles are congruent and apply those theorems. All right, so remember congruence. Same side lengths, same angles, same angle measures. If they have the same sides and the same angles, they're going to be the same size and the same shape. So same size and shape. Typically, we're talking about like two things. And in this one, we're going to talk about triangles. Okay, so assertion. Somebody is asserting something. So through two distinct points, so two distinct points. Distinct means like different. It's a synonym. So through two distinct points passes a unique line. That's what they're saying. Yeah, A and B, you got a line in between them. Two lines are said to be distinct, aka different, if there is at least one point that belongs to one but not the other. So two different lines. It's called a C and D. So there's a point C that is not on line AB. So those are two different lines. Otherwise, we say the lines are the same. Got it. I wrote a whole paragraph about this. Lines that have no point in common are said to be parallel. So a good example of that would be this ruler. So I know this ruler is these lines are never going to touch on this ruler. So those are lines that have no point in common. So given two different lines, either they are parallel or they have exactly 1 point in common. So here's the other example. Let's call this EF. So we got line EF. Here's a different line. We'll just call this GH. So you can conclude, given two distinct lines, they're either parallel, like the ruler edges. Those are parallel. Or two different lines, they have 1 point in common. And that's where they intersect. Just call that I. So what do you notice? What do you wonder? Take 2 minutes. Write down a noticing for two lines that intersect in 1 point. Write out wondering. So one of each. And then do the same over here for notice. write something down, and wonder, write something down here. Okay, so once you're done with that, so write your noticing and wondering for the ones that touch in one spot, and write a notice and wondering for 2 parallel lines. When done, come see Mr. Fisher and bring your workbook. So just show me your workbook that you completed it. Okay, you also want to pause the video. So pause the video when you're done with the notice and wondering for each. Bring me your workbook, and then you'll move on to 7.2 right here. Okay, 7.2. Proving the angle, side, angle, triangle congruence theorem. We get to prove it. Cool. So, 2 triangles. So we've got 2 triangles. So there's a triangle, there's another triangle. They have 2 pairs of corresponding angles congruent. Okay? And the corresponding sides between those angles, this is a keyword, between, are also congruent. So sketch 2 triangles that fit this description. So here we go. I'm gonna do let's see, I'm gonna do a line that is 1 inches. Oh, might as well go over here. Let's do 2 inches. You disregard this little spot right here. So you got a line 2 inches long. Let's do another one over here. This one's also 2 inches. Okay. And they have 2 pairs of corresponding angles congruent. And you know that the side has to be between those angles. So let me start over here. I'm gonna do an acute angle, like coming off this one. Let's say it's up to you on this. So your 2 triangles, get creative. You don't have to copy me. So no need to copy me. If you copy mine, I'll give you 1 point. If you do a different 2, I'll give you 3. How about that? Okay, so if you just copy me, I'll give you a point. And if you do 2 of your own triangles, I'll give you 3. Okie doke, so the first one, let's see, we got to set an angle. So for me, you just set the center. You're gonna have a protractor that has a little hole in it. You wanna make sure you put this point like right in the hole. And then you gotta make sure that the line on the protractor is parallel to the line that you drew. All right, so I'm gonna say 20 degrees on mine. So see that 20 right there? There's a 20 right there. It's also 160 if it was obtuse. I'm gonna use this 20-degree marker right there. So this is gonna be 20 degrees, this angle over here. And then over here, I'm gonna show you like how the obtuse angles work. So again, put the vertex or the dot right in the center of your protractor. Most of you have like a little hole in the plastic, so that's where you put it. I'm gonna make this one, let's just say 130. So 130, okay. So I know this one's gonna be 130 degrees. All right. Just gonna draw my line to about there. I know it has to go through this point in order to draw a 130-degree angle. And this one has to go through this point. So now I have a triangle with a 20-degree angle and a 130, and then this again is 2. And I'm just gonna color it in for good measure. Okay, so there's my first triangle. And if you just copy my idea, 20 degree, 130, and 2 inches, I'll give you 1 point when you're done. Okay, let's move on to this one. We got a 2-inch line, right? And then I'm gonna have a 20 going this way and a 130 going this way. So here we go. So my 130 marker is right there. Just gonna get it started. So that's 130. And then let's do the 20. This is where you gotta be real precise. So there's my 20. See the 2, 0. So we got a 20-degree angle. And a 130. And then this is 2 inches right here. Let's color this one in. Okay. That was number 1. So we are done with number 1. Let's look at number 2. Label the triangles W, X, Y, and D, E, F so that angle W is congruent to D, angle X is congruent to E, and side WX is congruent to side DE. Okay. So let's go W. I'm going to need WX to be congruent to DE. So I'm going to make the WX be the 2, which I know is going to work, which makes this a Y. There's your Y, so WXY. Okay, so W's got to be congruent to D. So my 20-degree angle over here needs to be D. So there's D. Angle X, my 130, has to be congruent to E. So we're going to make that E. Got two 130s. And side WX, the 2, is congruent to DE, also 2. Okay, cool. So I know then that this is F. And if you want to color them in, be my guest. So W, X, and Y congruent to D, E, F. That's what we're going to find out next. Okay, so step 2 is done. Now let's look at number 3. Use a sequence of rigid motions to take WXY to DEF. For each step, explain how you know that one or more vertices will line up. Okay, that's cool. It's easy. You will need patty paper for this. So here we go. W, X, Y. So you got W, X, and Y. Let's connect the dots on these. Okay, so this is 20 degrees. This is 130 degrees. And this is 2. All right, so I know W corresponds to D. So why don't we just go translate W to D. I know X corresponds to E, so why don't we rotate counterclockwise until X lines with E. And then lo and behold, Y lines up with F. Now, how do I know these vertices are going to line up? Well, W, we already said, was congruent to D. X is congruent to E. WX is 2. DE is 2. Because this is a 130-degree angle, you know that XY is going to align with EF. And because this is a 20-degree angle right here, you know that WY is going to line up or align with DF. So let's just talk about it. Translate W to D, rotate center D until X lines up with E. And that was counterclockwise. So let's try to remember that when we write them down. So, step 1. We're going to write the rigid transformation. That's what they asked us to do. All right, so step 1, translate. And let's just call this the specifics. We're going to say W to D. W will align with D because you can always translate a point like W to another point. In this case, D. You can always translate a point to a point. Okay. Then we're going to rotate. Now, what are the specifics? We're from counterclockwise center D until X and E align. Let's talk about that. So rotate counterclockwise. Center D until X aligns with E. And then they asked us, how will you know that one or more vertices will line up? Well, we know X will align with E because the length of WX is the same as DE. And you will find that if you have two angles, 20 and 130, and the side length that's in between them, 2 inches, if you have the angles and the side in between them all congruent, these two triangles are congruent, and that's known as angle side angle. All right, let's move on to a couple more problems related to this new thing that you learned. So lines L. Oh, and last but not least, before you move on to 7.3, show me your workbook. And for this one, I will give you, like I said, 1 point if you just copied me, 3 points if you did different triangles. And then if you do number 3, I'll give you another plus 3 points. So you can score up to 6 points on 7.2. All right, finding the missing angle measures. So lines L and M are parallel. A equals 42. So we gotta find B, C, D, E, F, G, and H. All right, so these two lines are parallel. There's a line that they don't even name, but that line is called a transversal. This is from Unit 1, lesson, it's either 19 or 20. Can't remember off the top of my head. But this is what we learned in Unit 1. So remember a couple things. We learned about vertical angles being congruent. So remember, you got a line and a line. V, A. 1 and 2 are congruent. 3 and 4 are congruent. So vertical V, A. Let's use some Christmas colors. Vertical angles are always congruent. So let's do that. So C will equal 42. Easy peasy. And then linear pairs add up to 180 degrees. So you're gonna find 42 plus B. So 42 plus B, 42 degrees plus B equals 180. So you just gotta subtract 42 to both sides. And B will equal 180, these cancel out. 180 minus 42, so B equals 138. So B is 138. Let's triple check I didn't make any mistakes. 138 plus 40 is 178, plus 2 is 180, so we're good. Then let's go back to the vertical angles principle. So you know now D is 138. Okay. Now we know that corresponding angles are congruent. So you got a 42 right here. That means that this transversal cutting across parallel lines means that E is 42. Look at that, 42, 42. You also know alternate interior angles are congruent. 42, 42, good example. Corresponding 42, 42. Alternate interior. So then this 138 over here is the same for F. So F will be 138. And now you can just go back to vertical angles. Super easy stuff. So G is 42 and H is 138. You'll be able to get to the point where this takes you like 30 seconds. These are so easy. But we're going to really use alternate interior on this next segment. So yeah, show me for 7.3, show Fisher. So this is a checkpoint. And I'll give you 2 points for this. So you got 3 up for grabs, another 3. And then show me 7.1. All right, let's go on to 7.4. It's thrilling stuff, I know. So quadrilateral ABCD is a parallelogram. Easy way to draw a parallelogram is just to draw, just use a ruler. You got to make things like the same length. So let's say, well, let's make them each an inch. How about that? Oh, 1.5 inches. How about that? So from 3 to 4.5.
John?
Yeah, I'm on a video. What's up?
Can you text Mandy and send
Yeah.
It's dark outside.
I'm like in the middle of a video which requires my phone. Is there any chance you could for me?
Yeah, I can.
Okay, thank you. All right. So you got a 1.5 inch side there. It's like right there underneath the H. So why don't we just go here. Okay. So if you had A, B, C, and D, remember, ruler, got parallel sides. Well, we just make these green just for fun. Okay, so you got two green sides, A, B, C, D. They're both 1.5. 1.5. Okay. Let's connect the dots here. So A, B, C, D. This side is parallel to this side. Sketch parallelogram ABCD and then draw an auxiliary line to show how ABCD can be decomposed. That means like deconstructed. So we're going to draw a line either here or here so that it makes two triangles. That's what that's saying. So that's pretty easy. Why don't we just go B to D? This is an auxiliary line, this dashed line. An auxiliary line is something, is a line you draw in geometry that helps you. That's an auxiliary line. This is it right here, BD. Now you gotta prove that the two triangles you created are congruent. And then explain why that shows that one pair of opposite sides of a parallelogram must be congruent. Okay. So I see where they're going with this. The first thing I'm gonna say is you have parallel lines here, right? And you have a line cutting across parallel lines. This auxiliary line that we drew is a transversal. So a transversal across parallel lines means that alternate interior angles are congruent. meaning that this one congruent to this one. So I guess we'll go red and orange today. So you got the two orange ones are going to be the same. The two red ones are going to be the same. And they share this transversal. So we can then say that this line, because it's shared, is also congruent. So there we go. We've got the two angles plus the side in between. So prove that the two triangles you created are congruent. So we're gonna say triangle. That's your symbol for triangle. And call this one ABD. So triangle ABD is congruent to triangle. Now this is where it gets tricky. A has to correspond to the first letter of the second one. So A and C are corresponding, so we're going to say C. If you go A to B, C is going to go to D. Because look, A to B, the orange, C to D with the orange. A, B, D, we end on the red one, C, D, B. Okay, they are congruent because of what we just learned. That two triangles are congruent if, let's just go back to 7.1 to cheat a little bit. If they have two pairs of corresponding angles congruent and the corresponding side between those angles congruent. So if we have two pairs of corresponding angles congruent and the corresponding side between those angles congruent. Why would that show that a pair of opposite sides of a parallelogram must be congruent? Well, because if ABD is congruent to CDB, then AD is congruent to CB. So if triangle ABD is congruent to triangle CDB, then opposite sides AD is congruent to CB. Okay, last but not least, when you're done with 7.4, show me your work. Just use a ruler to create your parallelogram. And we'll even show you here. The only thing I eyed was the distance from the letters to the points, so if it's a little bit off, that's why. So we said ABD congruent to CDB. So ABD congruent to CDB. So if I knew the length of this, I could just do a 180 rotation to get there. But I don't know the length off the top of my head. So I'm just gonna go A to C. Oh, let me just connect the dots here. Okay, so ABD, CDB. So A to C. Then we're gonna rotate. I gotta get D to B. So if I go like that, D's on B. There we go. ADB. Sorry. ABD congruent to CDB. What do you know? All right, that was lesson 7, 41 minutes plus, let's see, 41 to 43 minute video. Well, that was the second thing, actually third thing we did. The second thing we're gonna do is a brain break. And the first thing we're going to do is quiz 2. So quiz, unit 2, quiz number 2. Excuse me, number 2, which covers lessons 4 and 6. So that'll take 30 minutes. Brain break is 10 minutes. So we got 30 plus 10 is 40, plus about 43. That's about 83 minutes, plus you got about 7 for pausing and showing me your work. Cool. All right, always homework is the practice problems, all plus the lesson 7 cool down, which is right here. And I will demo that on the cool down video coming up. But I want you to try this. Well, might as well just do it. Let's just do it. Oh, okay, easy. All right, so far you've proved that AD is congruent to CB, right? So let me just do this. So A, B, C, and D. I'm just gonna keep it rolling. So A, B, C, and D. So remember, these lines are parallel, right? We've already proven that AD is congruent to BC. Now we got to prove that both pairs of parallel sides are congruent. So then we got to prove that AB is congruent to CD, which is easy because we already proved that these angles are congruent. So angle DBC is congruent to angle BDA. So this angle is congruent to this because alternate interior angles are congruent. Therefore, CDB, this angle right here, will also be congruent to ABD. So step 1 is these two, step 2 is these two. So angle CDB is congruent to angle ABD. Same reason. Alternate interior angles are congruent. So then the step 3 is that BD is congruent to DB. So BD congruent to DB. Why? They share the side. So both triangles share the side. So therefore, triangle ABD is congruent to triangle. Got to go in order. So A and C, B and D, D and B. Triangle ABD is congruent to triangle CDB. Why? Angle, side, angle, congruence theorem. So therefore, AB, this side here, is congruent to CD. And why is that? Well, corresponding sides in congruent triangles are also congruent. Okay, that's lesson 7 with the cool down. It took 50 minutes, so 50 plus 30 plus 10 is 90 minutes, which if we get it all done, you should have a little bit extra time to relax. But anyway, that's lesson 7, unit 2, and make sure you do the cool down plus all the practice problems for homework. And while you're doing all this on video, I am grading your tests, so everybody wins.